Hello everyone. So today we are going to work on this 3D grid system for the planet that we have implemented. So the reason is that I need a way to select the surface area on the planet to implement an LOD system. And previously I experimented with this sphere grid system, but that didn't work quite as I expected. So that's why I thought of switching to this type of a grid system. So here basically what happens is my planet surface area is divided into these cubes. So when the character is inside or in one of these cubes, that cube will be considered as the closest cube, and whatever the mesh part inside that cube will be considered for LODs. And to demonstrate that, here let me land my character somewhere like here and here. Now pay attention that this area is like a sharp line. Now once the load system kicks in, you can see now we can see more details. So here, if I turn on the wireframe view and detach from the character, let me go away and enable the wireframe view. Now here you can see these LOD enabled areas have a higher poly count compared to the rest of the planet, and as you can see here around the character, it keeps increasing the level of detail on the planet surface. So now this looks a bit weird because the cubes are in the world space. Here, let me go back to the world space, and yeah, now you can see the cubes are in the world space. That's why they look kind of rotated when we were standing upright or when we are in the planet gravity area. Okay, so still the load system is a work in progress, but already I have implemented some LOD system here. So first, and also you can see in these regions that we where these cubes in the edges, you can see a bit higher poly count. So I haven't worked out how to avoid that yet. So yeah, as the first part, I'm gonna work on how to create this cubes or 3D grid system, and after that I'm gonna look into the how to increase the level of detail or how to increase the poly count and add more details to the planet mesh. And before we get started, I'd like to remind you, you can download the project files of this project and all other thousands of projects that I have done. So to the date, there are over 1800 videos. For each video, you can access the project files in the Patreon page. I'll leave the link in description below. Once you become a member, you can download anything without a limit. So yeah, now let's get back to today's tutorial. So here, this is the planet, the randomly generated planet that we have implemented. So now let me first open my planet blueprint, and here I'm gonna add a function. I'll call it draw box grid. So as I said, the first step is figuring out how to have a grid that allows us to select surface area within that grid for each tile, not exactly tiles, cubes, because we are not dealing with the flat landscape, we are dealing with the planet. Okay, now to get started with, first we know the radius of the planet, but it's in kilometers. So let's add a new variable because we gonna need this in multiple places, so it's better to have a separate variable for that, radius, but in centimeters. And I will not make it visible in the detail panel because this will be calculated based on this kilometer value. And I put this up. Okay, so kilometers multiply by 1000 to make it meters, and multiply by 100 to make it centimeters, which is same as unreal units. So I'll do that in the construction script. So whenever we make any change to this radius in the detail panel, it will be applied here. So we will have the updated value here. All right, now we have the radius value now, and if I get actor location, and from this, if I into this, if I add the centimeters radius, this will give us the max point of the grid. So I'll promote this to a new local variable. I'll call it grid max. So the max point of the grid. And then similarly, if I subtract the radius from the actor location, this will again give grid main value, right? Now to demonstrate that we have the correct values, let's draw a debug line using grid max as the end and grid mean as the start. Let's make it red for 10 seconds, 5000 units, and I'll make this call in editor. Now we should see, if I press this draw box grid, now you can see this line that goes across the planet, and I can see this is the max point, this is the mean point. Alright, so our points are correct as far as I can see. So the next step is drawing the cubes within that area which represented by this max and mean points. So for that I'll have another variable. Let's call it box size. This should be I can use a float, and I think I will have to use something like 200,000 because our radius is 10 kilometers. So maybe 2 kilometers, one box size. That means the length of one side. So these are cubes actually. Okay, now then we can get the radius in centimeters and divide it from the box size like this, and we can get the seal value. So this will give us how many boxes that we need to draw. Actually we might have to multiply this by 2 because here we are considering radius from the center of the planet. So to up this number of boxes, to down the same number of boxes, so we need to multiply it by 2. I'll promote this to a new local variable. Let's call it box count. Right now, so as I said previously, we are dealing with the 3D grid. So to draw a 3D grid, we would need 3 for loops, and starting point would be 0, ending point would be this box count. and as I said, 3 for loops, because we have to count along x-axis, y-axis and z-axis, right? Okay, all right, what's next? Now we can make a vector using these 3 index values. X, I'll consider this as y, and then z. Okay, now if I multiply this by this box size, I will get this point from the cell. I will get this point in the space of this box, which is the center is the planet center. So in order to get, no, not actually, not the planet center, because we are going from 0, so that would mean the lowest point. So into this I can add the grid mean, so we will get a point. The 0 0 will represent grid mean, and it will go from grid mean to grid max. So we got a point. Now to visualize this, let's add the draw debug box, and I'll use this as the center, and as the extent I think we can use this box size, but we will have to divide this by 2, because here we need to give extent. That means extent is calculated from center of the box to the edges, so this needs to be divided by 2, right? And rotation I'll keep as 0. I'll keep it drawn for 10 seconds. Thickness, as I know it, we need something like 5000 to clearly see in this scale, right? Now let's compile and draw a box grid. See, now we have a box grid, but we have boxes in the area that we don't really have the planet surface to. So now we need to eliminate that areas, those area, the boxes that are completely outside the surface area of the planet. So figuring that out is actually not that hard. So we can get this point. So as I said, this would represent the point in the space of the planet, in the local space of planet. Let's do it like this. Let me add a readout node here, and also a readout node here. Then let's collapse this. Is on planet surface, is on surface. That's enough. Okay, now here what we can do is I'll change this location, and we can get the distance from this location to the planet center. Get that the location, and then if this distance no, we can subtract the radius from this value, and then let's assume Well, we can later on change this. Let's assume the highest mountain peak or lowest valley or lowest point in the on the planet's surface relative to the 0 point. That would mean something like mean sea level, or the point that is distance from the center of planet is exactly as radius. So if those 2 points are within 20% of the radius. So I hope that makes sense. So let me multiply this by 0.2, and if this distance, so I'll get the absolute value and check if this distance is less than 20% of the radius. So that means all the mountain peaks and all the lowest points or valleys lies within 20% change from the radius. If this is true, let's have a branch. I'm gonna consider that point we consider here as a point on surface. So only then I'm gonna have a output exit here. So like this. Now if I draw the grid, you see only the cubes that have some part with this mesh. Here you have an exception. Oh, not really. See, so the boxes that does not contain any surface area is ignored, and also there will be no boxes inside, see, inside the planet as well. Only on the surface, only along the surface we have now boxes. Okay, now we know, now we have a proper way to calculate those boxes. So I'll change this function. Instead of draw box grid, I'll name it initialize 3D grid, and then I'm gonna save these generated points to some data structure. So I'll, for now, yeah, earlier we needed a grid. No, we need a separate one. So let's say I'll call this 3D grid, and this should have vectors, and I'll convert this to a map, and this will have a vector and an integer value. So the vector will represent the midpoint of the cube in this grid, and this value will represent LOD level, the current LOD level. We will need that later on. And then here, when I initialize this 3D grid, I'll get the 3D grid, and let's clear it first because I might be running this multiple times. I may have run it multiple times. And then in here, let's add values to the grid. Well, this is going to be the point, and this I'll leave it at 0 for now. That will represent whatever the default LOD level. Okay, and one more thing, I'll change this box size. Well, I'll add a new variable here and I'll call it LOD. No, not LOD. I'll call it grid cell. Let's call it grid size. No, why can't I have it? Grid cube size. Okay. And this has to be just a float, not a map, just a single value. And I'm gonna use the same value here. The reason that I converted this to a global variable is we might need this value when we do the calculations for the LOD system. And I'll replace that with, oh, I don't have this option. Why not? No, doesn't matter. I'll manually replace it. Where else I have the box? Here. Ah, now I have. And let's get rid of this. Alright, let me check for the one last time that we still have the, oh, this is a pre-grid. Here is the 3D grid. Okay, here is our 3D grid. And yeah, so I'm gonna stop this episode right here and I will work on the LOD system. I will continue with the LOD system from next episode onward. Don't forget to like and subscribe. And thanks for watching. As always, updated project files will be available for the download in the Patreon page. Link would be in the description below. And see you in another episode. Goodbye.